Hello 3M, this is our first video, day number 2. We're talking about functions and relations today. So a relation, and it's impossible to come up with a definition that doesn't have the word relationship in it, but it is a relationship between any two things. So you could have a relationship between students' names and their math score, the number of people in a town and time. So let's just write an example. Students and marks. Height and time. Kind of doing mathy examples there, sorry, but anything that you could put into a graph is what we call a mathematical relation. Not all relations are functions. A function has a special definition. The first one is the most important one, but it says that there is one y value for every x value. Or there's only one output for every input. A second way of determining if something is a function, which would be helpful to have in your notes, is what we call a vertical line test. If you have a graph of a function, a vertical line will only touch it in one spot. Two other words that we really need to know well, and we'll have a record of it here, is the domain and the range. The domain, first of all, are acceptable x values. So what makes sense for my values of x? For example, we often have time on our horizontal axis. Does it make sense to have negative time? Does it make sense to have time go on and on forever or only up to 10 hours? The acceptable x values would be the domain. The range would be the acceptable y values. For instance, when we were looking at quadratics last year, we often talked about height. Does it make sense to have the height of a ball be negative? Would it make sense to have the height of a ball be 10,000 meters? Probably not. So there's probably a range of values that would make sense for your y values. Here are 3 examples that might help to clarify. So I have a table of values, x and y, that I could put onto a graph if I wished. But for every x value, there is one y value. So I could plot that and have a series of points, and a vertical line test would not be violated. Example number 2. I see that there is a problem. For an x value of 5, the y value could be 3, or the y value could be 4. That is a problem. To be defined as a function, every x value has one y value. This is a set of ordered pairs, the third example, which I could also plot on a graph if I wished, and sometimes that's a faster way of telling if something's a function or not. But I'm going to look at my x values and make sure that for every x value, there is only one y value. I see I have a problem. For the x value of 2, my y value is either 4 or 6. That is a problem. So the only one of these 3 that is a function is the first one. All 3 of them are relations, but just the first one matches the definition of a function. The fourth example is a mapping diagram. So Seyron maps onto 8, Ahmed maps onto 7 and 10, and Sarah maps onto 9, and so on. So the first part of the question suggests we write it as a set of ordered pairs. So I would do a curly bracket, and I would say my first ordered pair is Seyron, comma, 8. And the second ordered pair is Ahmed, comma, 7. Third one is Ahmed, comma, 10. Sarah, 9. And Bob, 8. We could draw a graph of this where we had names across the bottom. The names are our domain. And the range of values is just 7, 8, 9, and 10. This one helps us to understand a function and if it makes sense or not because we have names of students and their score. And we can see that this is not a function because we have Ahmed with a score of 7 and Ahmed with a score of 10. So for any x value, we have two different y values. That's a problem. This is not a function, but it can help us make sense of it because can you have two different scores on a test? Not in my classroom. That is not a function. Please take a moment and do 2.1.5 by yourself. Just hit pause and see if you can tell which of those are functions and which are not. We are going to do an activity in class about letters of the alphabet that you could walk or not walk with the CBR Ranger. So leave that page blank and we will be working on that in class Monday. I'm going to do this sheet with you, function or not. So this is nice because we have three graphs to work with and a mapping diagram. Number one, for every x value, there can be only one y value. That can be harder to wrap our heads around in a graph, but the vertical line test is super easy. So if I draw any vertical line on this graph, it should only hit the graph in one place. And you can see that even as it gets steeper going to the right, I will always be able to draw a vertical line and only hit that graph in one place. So this is a function. Graph number 2. If I were to draw a vertical line, in some places I would be fine, but it gets violated right here. This is not a function, because my vertical line test has hit that graph in 3 places in one spot. Number 3, even with just points, I can draw a vertical line and it hits my graph in 2 places. That is not a function. I can see that for the x value of 4, I might have a value of 14, or I would have a value of 16. Since I have 2 y values for a given x value anywhere, that is not a function. Lastly, example number 4, my mapping diagram, x maps onto y. I have 1 mapping onto D, 2 mapping onto B, so far so good, 3 maps onto C, and 4 maps onto C. Is that a problem or is it not? That is not a problem. For every x value, there is only one y value. So I'm allowed to have 2 values map onto C as long as I didn't have 3 mapping onto C and 3 mapping onto D. That would be a problem. This one is in fact a function because we have one y value for every x value. 4 graphs we're going to spend some time with over the course of the next few months. Graph 1, Graph 2, Graph 3, and Graph 4. Can you take a moment and decide if all 4 of them are functions or if some of them are only relations and not functions?